My name's Ben Waters, and I'm the co-founder and director of SI Projects. The process of photogrammetry is a little bit like constructing a digital model from image-based information from various angles. So what we do is set up a photo stage that is a 3D scanning studio where we can place objects within the studio or stage environment and take many photographs of different angles and different positions and different scales of the object. Using these images, we can construct a 3D model in our digital software programs. And that process is really about ultimately constructing the 3D model through points, through lines, and then through surfaces. And we end up with a highly accurate, high-resolution 3D surface geometry that represents the model digitally. We can then, and this is the great thing about using photogrammetry, is use our high-resolution photographs to produce image textures and project those image textures onto the surface geometry of the models. And this is where we can get this fantastic engagement with the material characteristics of the objects throughout the collection. So one of the big challenges for us in the project was to adapt and change our process according to the differences of the objects in the collection. For instance, our process of capturing a large terracotta tile varied significantly from capturing a small metal nail. And those differences in the capture process related to how we set up our equipment and to understand the relationship between the real object and ultimately the process of creating a 3D object. That means that we need to use different lenses in our photography equipment. We need to plan the photo stage in a particular way spatially that has to be different. And we also have to think about how we're going to calibrate and measure scale in the software. So part of the process of photogrammetry is to be able to capture not only the objects themselves, but also to calibrate scale. And we use small circular barcodes that we've printed to allow the software to scan and to position specific X, Y, Z coordinate positions in space. And in doing so, we can calibrate both the scale and orientation of the models so that that carries over into our three-dimensional reproduction of the object itself. So that process allows ultimately for the presentation of the object to be able to be scaled, to be studied, to be measured, and to be orientated in a particular way. That's really important for the ultimate outcome for these objects, which will be presented for research, teaching, and learning purposes on the online platforms. So scaling a nail that is only 2 centimeters long and capturing this in high resolution was a real challenge for us. And it meant that we had to scale down all of our equipment. That was to use smaller targets that were printed out and reduced in scale, to use macro lenses on our camera to be able to capture detail at that smaller scale, and also to be able to produce enough data that we could produce an accurate 3D model of such a small scaled object. The challenge is to create enough image information all the way around the object in 3 dimensions so that the program can stitch the multiple images together to create a successful model. When you view objects such as the tiles, you can see a huge amount of difference and variation in material texture, from the original terracotta to dust to lichen and moss that's grown on these tiles over time. I feel that is a really beautiful and engaging part of these objects presented in this format. Those objects were really challenging to capture too because of their depth and length. During the photogrammetry process, when we're setting up our photography, we need to be careful to be able to get the object in focus all the way through the image. And so being able to control and understand focal lengths is an important part of the image capture process for 3D scanning. The processing of the images in the software that we use is highly complex and really intelligent. The software can pick out particular images that are in focus and pick out images that are out of focus and create a model using the specific focused images for the image texture, which helps create those beautiful high-resolution image textures that you see on the models. When viewing these models produced through the photogrammetry process, one advantage we have is to be able to turn off the image texture in the program. When you do this, you can see additional details that are underlying the material information in terms of its geometry and its surface characteristics.